All right. Hello, everybody. Welcome to calculus. So in calculus, there are three main ideas. Limits, there are derivatives, and there are integrals. So for the first few weeks, we are going to be talking about limits because limits actually help us define the last two things that I said. They help us define derivatives and to define integrals and what they actually represent in the mathematical world. So first thing that we actually need to know is what is a limit. So a limit, if you think about like in class, I like to do, what do you think about when I say the word limit? So people will say like, oh no, what did they say? Dang, I can't remember. That was too many days ago. But finding a limit, like when I think of the word limit, it's like the limit of my abilities. Yeah, it's pretty low. Okay. But the limit of my abilities is only so much that I can do. I'm trying to reach this thing that may be unattainable, but it's the most that I could do. It could also be the least of something that I could do. So like if I were to talk about the limits of this screen right here, here is an upper limit right up there. That's as far as I can draw up. If I draw on my paper or my desk here, you can't really see what I'm drawing, and it's useless. My lower limit is down here. As soon as I go below that, you can't see what I'm drawing right there anyways. So that's kind of an idea of what a limit is. Now what a limit is mathematically is, this is how it is notated. So the limit of f of x as x approaches c is how I may say that sometime is equal to some number L. So it is some number L. You may also say this, the limit as x approaches c of f of x equals L. Different people say it different ways. Nothing is incorrect there. But the limit, what it is just what are my y values approaching? What is my function value approaching as I get really close to this value c? For a limit to exist, the function must approach the same value from both sides. So you got to go to the same number from both sides. But it does not actually have to have a point there, because the important thing about a limit is it is what I am approaching, not necessarily what it is there. So hopefully as we go through this first example, that will make a little bit more sense about when and when we cannot have a limit. So find each limit if it exists based on the graphed function f of x. So they're telling us this is f of x right here. I like to write on my graph so that I remind myself as I'm taking tests and assessments and things. So the first part, I am given the limit as x approaches 4 of f of x. So when x is 4, what this is asking, I am getting really, really close to that x value right there. I need to approach the same y value from both sides. Whatever y value I approach from both sides is my limit. My x value is approaching 4. My x's are getting really, really close to 4, so they're getting close to 4 from this direction. They're getting close to 4 from that direction. The y values are getting really, really close to, I don't know, -1/2 or something like that. So from both sides, my y values are getting close to -1/2. No.
Again, any student with a last name
No.
O through S
Don't do it.
that has not had their picture taken.
No.
Go to the auditorium now.
They're not actually taking pictures if you don't go.
O through S.
No. No, they're sending students through. No. It's terrible. It's terrible what they do to kids. I'm just kidding. It's really just pictures. Okay. Anyways, so the next one. The limit as x approaches 0. Now my x values are getting close to 0. So I'm just saying, as I get close to 0, again, this is not necessarily what it is, but as I get close to 0, what are my x value or y values approaching? So looking at 0, well, there's a point up here. So at 0, it is 2, is what I would say. But I don't really care what is happening there, right? I'm just saying as I get close to 0, so as I come in for my function from 0, the y values look like they're going towards, this is by 2, I don't know, like -2.5 or something like that. So from both sides, and get rid of this line, even though it's not there, this is the part where like it doesn't have to be defined. It is defined, it is 2 in this case, but it doesn't have to be at that point. From either direction, I am getting closer and closer to that y value right there. So that limit as I approach 0 would be, I'm going to say -3/2. When you actually are asked this on a quiz or a test or something like that, you're not going to have to like guesstimate like this. You'll have some value that you'll be able to tell, I promise. Okay, so let's look at the next part. I am going to approach -2. So this is part C. The limit as x approaches -2 of f of x. So I need to get closer to x equals -2. So it looks like from this side, it's getting closer to 2. From my right-hand side, it's getting closer to -1. Now here's the thing. In order for this limit to exist, because it just says -2, the function must approach the same value from both sides. It approaches 2 from the left, it approaches -1 from the right. So since 2 is not equal to -1, I would say this limit does not exist. Don't bother me right now. If you write DNE, I am okay with that meaning does not exist. That's fine if you want to write that on quiz or test. These ones are not going to be a free response type question. So these will just be multiple choice. It's really like, did you get it right or did you not? Okay. The limit as x approaches -4 of f of x. So again, I need to get closer to this -4 value. It looks like it's going to 0 from both sides. So I will say that that limit is equal to 0. All right. So you won't always be given a graph. Sometimes you're going to be given a function. Most of the times you're just going to be given a bunch of random stuff like a function, or it'll already be filled out for you like these ones are down here. But every now and then you will be given a graph too. So they're going to give you it in any representation. You may even have it in a table or something like that. So for these, find each limit based on the function if it exists. So my function is a piecewise function. I have x squared plus 3. So x squared plus 3, except x does not equal to 1. So let me erase 1 and put an open circle there. And at 1, it tells me the y value is 2. Well, let's see, 1 it would have been at 4, so that point should be a little bit below it. So there's kind of my graph if I want to visualize it. So as I approach 1, I am getting close to where the function would have been, even though it's not really there. So what I can do is say, well, it should be getting closer to this part whenever it would have been 1, but it's not. So if I put in 1 there, then I'm going to come out with 4, just looking at my graph. My limit as I approach 0, so as I'm going in, let's see, approaching 0 from both sides, it looks like it would be the y-intercept, which the y-intercept of this graph is 3. As I approach -1, so that would be over here from either side, my y values are getting closer to +4. Again, that's a check. If I actually put in -1, it would be +4. So for my function, that would work as well. And then f of 1 is actually 2. Be careful here, because notice there's no limit or anything like that. They're just asking you literally, what is the y value when x is 1? So this is going back to Algebra 1, Algebra 2, pre-cal, all that stuff. If you don't see limit, then we're not talking about as the y values approach. I'm literally just talking about what is it at this point. Okay. So the next thing, what I want to do is talk about a couple of things where weird things are going to happen. So let's see, 1 over x squared. I'm going to type this in my calculator. I have a key press history down here too, so you can kind of see what keys I'm pressing if you are curious about what I am doing. So I'm going to type this into my y equals 1 over x squared. Oh, it didn't get my divided by. Come on. It's slow. I'm using my calculator actually attached to my computer. Okay, and if I look at my graph, let's see. It looks like at 0, the y values are going up forever. So since they are going up forever, as long as they are going to the same infinity, I can say that this limit is actually infinity. You could also say, or does not exist. Either one of those are perfectly acceptable answers. If you are going on to BC, I prefer you to have this one, this idea of infinity, because they are both going to infinity. If you are taking a multiple choice on your AP test, they could list one or the other. They could have infinity, they could have does not exist. They will not put both on that same question. And College Board actually says, the AP test people, they say this limit equals infinity. So I think that they would put infinity on the multiple choice. But our book that we have, the Larson book, it actually says does not exist. So they will recognize either one of those as acceptable answers. However, if I have a function that is just 1 over x, and I'm talking about that as it goes to 0, that one would be does not exist no matter what, because it goes to 2 different infinities. From the left, it's going to negative infinity, and from the right, it's going to positive infinity there. Okay, next one I'm going to look at is sine of 1 over x. Just so you know, in calculus, all we ever use is radians. So on your mode, it's weird, make sure that you are in radians. So that would be going to mode, making sure your radians is highlighted down there, so on and so forth. Okay, so on my y equals, I have sine of 1 over x. So let's see what the graph looks like. That's weird. It looks like it goes to -1 and +1, but let's zoom in. Let's zoom in. So zoom, I'm going to zoom in, and then I press enter.
Pardon the interruption.
They're trying to get more.
Student with the last name.
Okay.
E through Z. That
It
has
looks
not had a
like
picture
weird
taken.
things are happening, so
We
let's
will
zoom
get
in
to
more.
Oxford now.
Whoa.
T through
Okay.
Z.
Very weird things are happening. So I'm going to change my window, and it looks like my min is -1. So I'm actually going to go to, since I'm trying to look at 0, I'm going to go from -0.01, right? That's super close to 0, to 0.01. And sine has outputs between -1 and 1. I'll just go by that. That's fine. I'm going to change my x scale to 0.005. Just for fun. Okay, so now, well, okay. All right. Yeah, so that just doesn't make sense at all. I don't know what the heck is going on. And what's happening, you're actually going to be able to zoom in further and further and further and further, but nothing really makes sense here. Let me see if I can pull up Desmos. Desmos, sine of 1 over x, show it to me, please. Okay, yeah. So that is what's happening, that like red blob, I'm trying to stretch this out, is this, so like I'm trying to get, and it's just like, it doesn't know what's going on. Now I can't even do anything. But what this is this is called a discontinuity by oscillation. As you get closer to your x value of 0, the numbers for 1 over x become huge and really small at the same time, right? 1 over x is going to infinities around it. So if you do sine of that, then you're going to sine of infinities, and it's just dramatically changing. So this one, moral of the story is, does not exist. Don't put an equal sign. Don't put, why did I put, oh wait, yeah, that equals infinity. Or does not exist. So this one just does not exist. And the reasoning, you don't necessarily have to put this, but this is an oscillating function. That is a type of discontinuity that you did not learn about in pre-cal. Okay, so that's one that I want to talk to you guys about. These are the last two, which we will actually learn about in the next video if you want to watch the next video, or whenever you're in class and blah, blah, blah. But you will learn how to graph the, or mess with these algebraically, but I want to show you how to do it with a calculator. So I'm going to clear my history just for fun, and I'm going to type my function into my, actually I'm not going to do it like that, into my y1, because this is a nice trick that you guys can have. It's not catching. All right, square root is plus 1. Get out of the square root, minus 1, divided by x. All right, and I'm not going to actually look at my graph. I'm trying to approach 0, and I'm curious. Yeah, I can't really tell much, but that's a bad window. 6. So maybe it's 1/2. It's kind of hard to tell. But what you can do is you can actually change the table setup. So if I hit second and then window, what I can do is ask the independent variables so that now when I go to table, if I'm trying to figure out what is happening at 0, I could use like negative 0.01, negative 0.1, 0, I don't really know what's going on, 0.01, 0.1, and if I figure out what my outputs are, then it will be hopefully pretty nice. So let's see, if I put in x as negative 0.01, it's 0.5. Negative 0.1, oh, I did that backwards on that side. Oops. 0.01, 0.1. Okay, put these in the wrong spots. That was not in order, just delete. Negative 0.1. Right, so negative 0.1 was 5132. And negative 0.01 was 5013. 0.01 was 4988 and 4881. So it looks like as I get closer to 0, the y values, I would say, get closer to 1/2. So that is one way to do these things, such that with a calculator you can tell what the values are approaching. And you can do it very quickly by putting your function into your y equals to do this. So let's look at another one. Again, we'll figure out how to do this algebraically in the next lesson. But if I go to the next one, I'm going to go to my y equals and clear what I have. I have x cubed plus 27 over x plus 3. If I look at my table, so now I'm approaching negative 3. So maybe I would want to have like negative 2.9, negative 2.99, and why not? Negative 2.999. Right, so that's getting closer to negative 3 from the left side. Looks like it's getting close to 27. So let's go in from the right side, where I have 3.1, 3.01 is closer, 3.001, but these all need to be negative. What are you doing? What are you doing? There we go. Okay, so now negative 3.1 was like 28, so that's kind of far off, but we can tell as I get closer and closer, it's getting closer to that y value of 27. So this is a way that you can use technology to figure out kind of what limits are and what they are approaching. We're just taking the x values and seeing what the y values are getting closer to in order to state what the outputs are going towards as well. All right, hopefully this was helpful, and I will see you guys soon. Bye-bye.